I'm Dr. Thomas McKenna. I'm a program officer at the Office of Naval Research. So there's substantial losses incurred when you have a major fire, when you can't suppress it at an early stage. SAFFiR is the shipboard autonomous firefighting robot. And this is a program that's been going on for about 5 years, basically to develop a humanoid capable of fire suppression.
My name is John Farley. I work at the Naval Research Laboratory, and I'm the director of the Shadwell, which is the Navy's fire test ship. If we have a shipboard fire, we have to be able to quickly get it under control and then regain the ship's ability to maintain its fighting mission. You know, we have not only the ship, but we have ordnance on board, and we have a lot of flammable systems on board. Sometimes it's hard to keep the sailors up to the latest as far as training is concerned. Or sometimes they could create an environment and make it worse. Now the robot could be trained and constantly updated to make sure that the conditions are not as bad as what a human could make it.
Well, our objectives for the demo on the Shadwell were to show that the robot could walk over what was a very uneven floor, that it could orient itself to the fire, that it could autonomously handle the hose, operate the hose, aim the hose, and suppress the fire, which it succeeded in.
I'm Brian Latimer. I'm an associate professor at Virginia Tech in the Department of Mechanical Engineering. I think robots are well suited to be sent into those environments, and bipedal humanoid robots are particularly good for those applications because even in the tight, confined conditions that you might have inside of structures, these types of robots can be designed to maneuver in those conditions. SAFFiR is an electromechanical robot, so it's driven by batteries and all the motors are electrical. So we put a rain gear type suit on the robot just to protect it from those types of basic steam, particulate, and water drop hazards. So we have visible cameras on board the robot. We have something called a LiDAR, which is a rotating laser that gives the location of the points in the field of the view of the robot. And then lastly, we have stereoscopic thermal imaging cameras that the robot uses to detect and locate the position of a fire so they can suppress it.
We combined the notion of smart sensors in the spaces, microflyers that can fly even in smoke, go through those extremely narrow doors, that it could locate fires and operate in those hallways even in dense fire smoke. And it succeeded all those tasks.
So today was the first time we came on board an actual Navy ship. We were able to do a lot of things today that we hadn't done previously, and we have a lot of hope for new advancements in the future.
We have some fundamental issues in robotic mobility that we still have to address, as well as working out the human system integration issues. And we'll continue to advance the capability with better and better demonstrations. At the current time, the robot is teleoperated, so you have operators standing off with the computer console. Where we intend to go is to have a combination of natural language and gesture control.
The robot has gone through amazing transition within 4 years. And I think it's a worthy investment for a long-term project. But it's going to take a lot of time, a lot of dedication.
And we're working towards human-robot teams, what we call the hybrid force. Humans and robots working together.